Okay, let me kick this off. Well, officially welcome everyone to our webinar, which is a deep dive in knowledge bases. Today, I have Alejandro Cantu, who is the Senior Product Manager of MindsDB, and also Andriy Burkov, who will be doing a presentation with regards to our hybrid search and knowledge bases with structured data. So before we begin, we will see that there is a Q&A tab. If you have any questions throughout the presentations, feel free to post a question in the Q&A tab. We will answer them as we do the presentations, and we will also have a Q&A session at the end of the presentations where we will be answering everything live. Also, feel free, for those who only attended now, feel free to introduce yourself into the chat. Let us know where you're from, what you do for a living, and what your use case is with AI. It's very important to make sure that you post your questions in the Q&A tab and not in the chat, just so that we can directly reply to your question in the Q&A tab. So without further ado, I'm going to give over to Alejandro. Thanks, Ali.
Thanks, Chandra. Hello, everybody. First of all, apologies for the time scheduling inconvenience. I'm happy that we're here and we're finally able to get started. So, as Chandra said, I'm incredibly excited to be here next to Andriy to talk about knowledge bases and the stuff that we're doing in MindsDB. So I'm first going to start by sharing my screen and just going to do a couple of presentations to let everybody know what is MindsDB, what do we do, and let me know if you can see my screen. Yes, amazing. So for everyone that's not familiar with MindsDB, we are an AI startup. We're really focused in bringing data into the AI world, and we do it by this interesting way of doing things, which is like we want to connect data, unify data, and respond to that data. So any data anywhere with human level intelligence. So if you're not incredibly familiar with MindCD, we're one of the most widely adopted AI query engine in the world. We have more than 30,000 GitHub Git stars, more than 400,000 deployments. But really the main thing is because we enable developers and teams to connect to more than 200 enterprise data sources. So we do this with a zero ETL, different type of solutions. We are backed by some of the biggest industry leading tech partners, such as NVIDIA, Google, Snowflake. And we're backed by some of the top investors also in the Valley as a Y Combinator company. So also going to share with you, like, if you're wondering a little bit more, like, what exactly do we do at MindsDB? We have this really cool video. Let me know if you can.
Imagine your team asking complex questions and getting accurate, cited answers in seconds. AI has the power to unlock insights and transform decision-making. But the answers are buried in enterprise data and across the web: CRMs, databases, support systems, PDFs, and web applications. Even with in-house AI expertise, most enterprises struggle to connect large volumes of fragmented data to AI. Not anymore. MindsDB powers AI-driven analytics at scale so that your teams get the insights they need quickly. With MindsDB, you can search and discover AI insights across multiple data sources using natural language, analyze unified metrics, and get AI-driven forecasts with predictive analytics, and automate workflows for agents with your data. Data stays where it is, with hundreds of out-of-the-box integrations for databases, business systems, and more. No ETL, no bottlenecks in data engineering. Your data remains secure, and access controls are respected. What used to take weeks or months now takes minutes. Non-technical teams can explore data like experts and get trustworthy, explainable results, complete with source transparency and analytics you can trace. Global leaders use MindsDB to unify enterprise and web data, accelerate business insights, and empower business teams. MindsDB fits your enterprise needs. Configure your proprietary business rules, use the LLM of your choice, and apply granular access controls. And deploy anywhere, on-prem, public cloud, or hybrid cloud. Find analytic insights you can trust faster with MindsDB. Visit mindsdb.com to book a demo today.
So this video kind of makes my work a little bit easier. Hopefully everybody kind of like gets a bit of an idea of what we're doing here at MindsDB. But really, let's talk a little bit about like how do we actually make everything that we saw in this video kind of work. If everyone here is familiar trying to build out AI systems or trying to bring data into bringing your data into AI, it seems like there's a lot of different steps that we need to be able to do, whether it is like actually building the handlers to be able to connect to your data, ETL extraction tools, but there's also so many different type of features and opportunities that needs to be handled in able to create an AI product system that will make it out into production. It might be we really like want to be able to do is like help out and actually make all these processes inside of our own system. And basically is we are able to connect to enterprise data, basically through using one of our more than 200 data connectors. And then we really, depending on the use case, what are we going to be able to do with that data? How MindsDB is going to be able to bring that into your application. Today, we're going to talk a little bit about knowledge bases, but we have other type of opportunities, such as for cognitive engine to respond to like specific questions, as long as some other type of features that would go into this. So once you deploy MindsDB, you can really get your AI agents and app access to your data to answer those questions and insights that you've been looking for. So the main thing about here in MindsDB, and let's talk a little bit about this, is like, how do we actually make this happen? And what we really want to be able to do is empower users to be able to access that data and bring that closer to AI agents and apps. And this is done by our stack. And our stack really comprises of three different main components. First one, the connect, which is the federated query engine, which I just talked briefly about it, but really allows us to access more than 200 different data sources. You're able to query in SQL, and like a federated query engine will translate it to the native language of your data source. So you don't really have to do a lot of translations or anything around that part. That's really where the magic of the federated query engine goes into it. So if you want to do complex joins, bring different type of tables, one is Snowflake, one is Postgres, with MindsDB, we'll handle all the translations in the part and actually being able to bring that data right where we need it. The next stage is the knowledge base, which we're going to be talking here about. A lot of the data that we're looking to put into AI, it's either coming from the structured and unstructured data. So if we're able to add a knowledge base to be able to make sure that AI can actually understand and we can actually bring the data what we want it to do and find the right similarity and semantic search, that's really when we actually just see some really good performances on the systems and actually power all these rack components so we can really bring in the data and answer the question that we're doing. And the response kind of thing, which is our cognitive engine, really it's really at this point, like how do we actually answer the question that we go? So you have access to the data, either federated query engine, you have access to a knowledge base because of a vector store, embeddings, and all the metadata you're putting to this. Now it's time to really answer the question. And that's where the cognitive engine response ends, either by using, we're agnostic to different type of LLMs, so we can use open source LLMs, we can bring your OpenAI LLMs, you can bring Google's LLMs, and then eventually you start really answering all the questions that you're going to be able to put into this. And now talking specifically about knowledge bases. When we designed and built knowledge bases, we really wanted to be flexible. We understood that the problem enabled to how to be able to search inside of them or build them is incredibly variable depending on the use case of what everyone here is trying to build. So that kind of makes a really big difference. So we're using our unified SQL interface to make sure that we can just create and use knowledge bases via SQL commands. So we don't have to learn anything new. We're just going to be able to use this language that a lot of us are familiar with, but really helps us being able to do that. And we'll look into a little bit more details into it. You can do intelligent semantic search, which is basically the basic concept and more usefully known concept of knowledge bases. And we have a flexible model storage integration. You can bring your own LLM providers to create your own embeddings, or you can use open source embeddings. We really offer the flexibility to use different type of either vector stores of models and things to be able to actually build up with this knowledge bases. We also kind of like want to be able to do like, how do we actually make think that this maintains its value and keeps them working for users, even when like as a use cases or the data evolves. So in order to be able to find the data you're looking, we're able to do like this through hybrid searches. So we combine semantic search. You can also do keyword searches. You can do a different type of combination or just plainly semantic search. So the different ways that we allow users to be able to search within their knowledge base and bring the right result is, I think, the main and key component of what MindsDB does in their knowledge bases. We're going to show a little bit more about that. The next thing is also like automated data management, right? Like a lot of these data sources are living entities, like more data gets added into a data source and that needs to be automatically updated into a knowledge base. So we create like different type of technologies and we create different technologies to keep things updated, but also we handle all the complex infrastructure to be able to do this and create it on your own. So we'll do text chunking, embeddings, updates. We streamline the whole process. So once we create a simple SQL command, all these things happen in the background so the user can really just focus on actually delivering the right answer and bringing the right data. And finally, it's all about once you build a knowledge base and you start asking questions, in the end, it's all about like, was my knowledge base able to find the right document, to find the right data to answer the question? And if you don't, a lot of you might have some great QA pairing questions. You have like some dedicated infrastructure to be able to do this, but we also built in performance evaluations. So if you don't really have, MindsDB will help you understand like how good is your knowledge base. Can you actually find the data? And we'll provide analytics and metrics for you to actually analyze from a very analytical performance. What is the actual performance of the knowledge base? And if it's probably not what you wanted to do, we also provide the tools to improve it, like for different chunking strategy, different embedding models. There's a lot of things that we can really move to get those incremental wins, being able to make a knowledge base performant and actually bring the right data. So this is incredibly useful when we're building RAG systems. So I'm just going to go through a little more conversation about knowledge bases, and then I promise I'll let you down with Andriy, which is like actually what we're all here for, and we'll actually see how this actually works in progress. So really quick, I talked a little bit about like how do we use SQL to actually create these knowledge bases through the MindsDB SQL editor. So the main components of it is we have this structure where when you create a knowledge base, you give it a name, you use your different models, such as the embedding model, which will create the embeddings. You can choose from different type of perspective and different going to go. Did I lose the screen? Can people see my screen? Just sorry. Let me.
Sorry, I replaced it. I thought you.
Yeah, no, I think I got that. No worries. Let me just go back to this. Okay, just a second. And there we go. Okay. Awesome. So now as I was here talking about the embedding model, you're able to choose either like from OpenAI or different providers, and you choose the model that you want to be able to use. Then you also use your re-ranking model, which will help us really figure out like if the actual results that are coming in are relevant to the query that we provided in the actual search. And I also have different type of capabilities such as storage, metadata, and content columns. I'm not going to go incredibly deep into this because this is what this webinar is all about. We're going to talk about like how these really metadata columns really gives us the power to be incredibly precise on the way that we want to search inside a knowledge base. And now querying a knowledge base, how do we actually search inside of it? So I just have 3 really quick examples, but we'll show how like in a way how easy it is. We use the SQL command like select ID or relevance, or we can select a star from the knowledge base and where content equals query text. So we actually are going to input the query text of what we want to be able to find inside this knowledge base, and we have additional parameters. We can filter by relevance, we can do limits, so we have different type of things, and I invite everybody to see like the full-on person functionality coming in our documentation. And I talked a little about hybrid search, and I think hybrid search is really interesting. Once we really look into knowledge bases, the main aspect of knowledge bases is to be able to search via semantic similarity. But sometimes our queries are more keyword driven, and that's what hybrid search plays a good role. So we allow users to be able to search in their knowledge base, not only by semantic similarity, but also by keyword matching. And we use BM25 to figure out like what's the right, your keyword results are going to be based on this protocol, and you're able to figure this out. So If you have a query that's more keyword driven, you can use hybrid search to go into that. You want to figure out something that's more semantic driven, you go with classic, just semantic similarity. So in the end, really useful to be able to find data in your knowledge base, depending on just like some keywords. And lastly, a lot of what we're going to be talking about today is really our SQL algebra, this how MindsDB's knowledge bases are SQL algebra powered. And one of the things here that I think is really important is that when you look into search inside a knowledge base and you start looking into 500,000 documents, maybe 5 million documents, 10 million documents, that is a big set to be able to search and find an opportunity for. If you set the right metadata systems when you create your system, it really empowers SQL Algebra to be able to figure and find different type of capabilities and find different type of aspects to enable for you to actually do very specific queries and be able to find the right data in this search. So we combine not only semantic content search, traditional metadata filtering, also Boolean logic, and some advanced SQL features, probably like group by order or unions that allows us to really find inside of the knowledge base. So without further ado, thank you for spending a little bit of time with me. Now we're actually going to stop sharing and going to move back to Andriy. I'm going to be answering some questions over this. And before we move in, Andriy, thank you so much for joining. Thank you so much for being here with us. We're super excited to actually get this webinar started. And just again, for everyone that just joined, apologies for our scheduling issue, and we're glad that we're going to get started. So this is what we've all been waiting for.
Thanks, Alejandro. And yeah, I joined Alejandro in our apologies to respect the time. I know that we are all busy, and I appreciate everyone who stayed because I want to show you. So thanks for being here. So let me first talk a little bit about our previous webinar for those who were there. So in the previous webinar, what we did is we shown this knowledge base feature of MindsDB, which is relatively recent. And when I joined MindsDB as an advisor, I wasn't familiar with this feature at all. So I spent significant time to works from the user perspective and how it works on the background. And I asked a lot of hard questions to Alejandro, and Alejandro tried to dig into technical details to show me where to find answers to my questions. So I think that right now I'm with the internal organization of this feature, and I really like the way it's done. So as I said in my previous webinar, I said that the mindset of MindsDB is everything is SQL, and this is a very important feature because we have many specialists that have experience working with databases who are not necessarily strong developers. And these specialists were traditionally kind of excluded from analytics, machine learning, and such things. Historically, you would need to be at least like a scripter or some high-level coder. But what is cool today is that the specialist who knows SQL, they might execute separate SQL commands in which SQL or a message SQL server and so on. But then if the analysis or transformation of the data has multiple stages, they had to either talk to developers and say, okay, I have this query and this query, so I need to procure the sequence. So can you write a script that schedules this transformation? So they were kind of like excluded from the end-to-end life cycle. It wasn't fun. So I know that many of the DBA work with stored percent implementation this object with RDBMS or whatever DBMS, but it looks more hackish than it should. So what's cool with MindsDB is that everything is SQL, and there is also an SDK. And for example, an SDK for Python, where you can run within the Python script and create a very complex pipelines. And the last cool thing is that now with chatbots, you don't really need to be such an expert in Python to be able to create a data processing pipeline. So basically, what you should be able to do. So for example, on MindsDB, every documentation page now has this copy to clipboard button. So you might just click the syntax of how to define a knowledge base or how to create a vector store and so on. And you pay in chatbot and you say, okay, this SQL query that I created and I like, and then I have this other one. So write me the intermediary glue code in Python that connects my analysis in one pipeline, and you just read the result. You are able to verify that your SQL is preserved as is, and then you run it and you see whether the output is exactly as it was supposed to be or not, and then you iterate with the chatbot, and finally you have your pipeline. So you become, as a data specialist, you become totally self-sufficient, and this is really cool. So you can accomplish in your professional life much more alone than you would be able in the past. So this is just to explain to you why MindsDB is so cool. So everything is SQL, so you don't really need to so they wrote machine learning as SQL. So today's webinar. So our previous webinar was quite simplistic. So we just downloaded already existing movie. Each movie was a combination of short verbal description and some attributes like genre, year, title, and so on. So this time we make a step further to the more processing data. So we don't start with something with some structured data that is ready to be uploaded to the relational table. So we will take text like corpus of norms to some format that we can then upload to a relational database. So our data set today, just for fun, and then after the webinar, we will share the notebook, so you will be able to play. So to make it a little bit more fun, we took the corpus of Enron emails. So most of you, I'm sure, are aware about this scandal that happened in the years 2000, and thanks to one who decided to pay, I think, $50,000 to acquire this set of emails to make it public. He paid from his pocket. If you remember the name, it's a famous guy. I just lost it at the moment. So please write in the comment the name. We will thank him. So it's 500,000 emails that were exchanged between about 100 executives in the company who discussed the state of affairs of the company at the time, and many of those emails were incriminating, and all of them can be found in this corpus, and we will try to find a couple to see what's inside and try to answer some questions using these emails. So to start, what we have to do, so we will install MindsDB this is the drive. This is MindsDB SDK, so this is the Python API that we will use. We will also install pandas, and like the rest of this request is for the connectivity data sets. It's where the actual corpus is. It's on Hugging Face. This is just to show beginners while wait. And Spacey, we will use named entity recognition, so to extract different attributes from these emails, and then I will show you how to write those SQL queries that account the attributes. So Spacey is, I think everyone knows, is currently the most used and popular NLP Python package. And it contains already pre-trained models for various NLP, including named entity recognition. So to install a model, so it's not sufficient to just install Spacey. We also need to download a specific model, pre-trained model that we will use. So we run this query, and for it to complete, okay, it will download this model from the GitHub repository. Okay, so everything is installed. So now we will do a data set, and we will download the 100 plus emails. So the way we do it, so we import the load data set function from the data sets, so from Hugging Face. We will use pandas expressions to clean a little bit. So this is how you create a model. Well, it's not a model. Technically, it's like a process. So in Spacey, you load a specific model, and it creates an API called NLP, and this is to classify, to extract entities, and to apply different transformations to your data. So then we download the data set from Hugging Face, so specifically from this repository on Hugging Face Hub. We create a pandas, and this is a small utility function that will parse different information from the raw text of an email. So we will parse subject, body from to and date, just for to demonstrate what's inside. Okay, so when we run this again, so it will time to download. Normally not too much time. Yeah. So you see, we downloaded 533,703 emails, and these are some examples of the already parsed. So normally it's just a blob of text, but I think we show it in this beautiful format. So there is a unique ID for every record. We extracted from and to as email addresses. There is a date, and there is subject that in this case is just body for some reason, and this is some. It's so here subject is RE, and this is a part of the email. So this is what we will work with. So our goal in this tutorial is to create a knowledge base in which these fields will be as columns of a relational database, and this text will be available for semantic search. So it will be embedded into embedding vectors. And we will also, to make it a little bit more fun, we will also apply NER, so name entity recognition, to the text to extract organizations, persons' names, my mentions. So all the fields or that Spacie NER supports, and we will use some of them to show you how a search in a knowledge base can be done, not just based on the semantic similarity between the query and the text, but also to show you how to further filter the results so that the search is fast and as relevant as it can. Sorry, as it can be. Okay, so this is the data. So far we didn't create any knowledge base. We just downloaded a corpus. So corpus is just a set of text documents, and we parsed some of them to show what's inside. That's it. So now I will do a little trick here. So like as you have seen, the data set is quite large with texts, and we will process all of them relatively in a hard way. So we will first of all apply NER to each of them, and then we will also embed. So we will chunk the text into smaller chunk for our retrieval augmented generation. So all of this will be quite long to execute for the in order to create the database and then the knowledge base. So I will use this trick. So I will go into this sample mode. So in the sample mode, we will only apply everything to 1% of the data. So just to show you the process and explain all stages. And then we finish the first pass, and we obtain our initial knowledge base just for the 1% of the data. Then I will just switch the mode to full, and we will apply queries on the actual data set. So the full. So yeah. So the approach to create to create a knowledge base. Okay, there is a multiple steps involved. The first step is we need to transform our unstructured corpus into a collection of records, if you want. So as I said, like in this structured record, one column will be from, another column will be to, then there will be a text, and also we will add columns for additional named entities that we will extract from the text. So to accomplish all this, to create this collection of records, so we will clean our email, for example, replacing multiple new line characters with a space. So everything will become just one blob without new lines, multiple spaces with a space. Some delimiters we will remove them. Then we will have a function executive NER, and this NLP model. And so it will apply the NLP model to our text. And when in Spacie's world, you apply a model to a text, you have to obtain a document with some entity extracted, let's say specifications made, and so on. And then you can use some of these properties. So some of them you will need for your analysis. For some you can ignore. So we are interested in this specific list of entities. So we will extract persons, names, organization, money, dates, events. And the NER model used by Spacie is already pre-trained, so we don't need to teach it how to extract these entities. But again, if you for your business you need to extract some separate, like for example, you work in biopharma and you need to extract molecules or I don't know, scientific methods and so on. You can fine-tune either a model that comes with Spacie, or you can even train your own extractor or this based on it. By the way, I'm working on a tutorial about how to do this structured extraction by using the language model. So I will share it soon. So stay tuned. And yeah, so now we already have the applied to our text. Now document entities, and if entity label is what we want, we will save this extracted entity. So in the end, our entities dictionary will contain all the entities from the text, and this function return the entities. So here we will just reason whether we are in a sample mode or not to decide how much of this record, how many of these records we work with. So currently we're in the sample mode, so all is good. And now we will iterate over all the our records with the extracted entities, and we will create process all the information. So we will combine email ID from two that we already have seen with these extracted entities, and we will create these final records, and we will save the result into a CSV file. So in the end, our CSV file will email all the entities, including those extracted by Spacey, all saved as a separate column. So if I run this, so yeah, you see, we will not process the entire 533 thousand emails. So we will just process 1% of them, and we will continue. So take a sip of your drink if you have a drink. In the chat, Alejandro, I can answer something. No question.
Yeah, it seems like Alejandro is answering a current question in the Q&A tab. But as we wait, guys, feel free to just pop a message, and Andriy can answer the question as we wait for the process to be completed.
You can imagine that for 100,000, and I did it yesterday. It takes about I think 5 or 7 hours to process, but it's only to inject the data into knowledge base, and only because with NER step, which takes time. So if you already have your table with all with your data in the structured format, you don't need this step, and you can start by injecting the data in the knowledge base right away. And I will show you how it works in a second.
It is processing over 500,000 emails, so I think the speed is incredible.
Yeah, no, it's very fast, and the data set is quite large, so it feels really natural. Okay, so now we have 4,869 emails extracted. So we don't have the entire 5,000 something, because we had conditions in our cleanup that if the text is too short, we ignored it. So this is where this difference comes from, and this is our sample from this CSV file that we created. So just to see that it makes sense. So we still have our from, and to give you an idea of let's say the same message can be multiple person's name or multiple organizations. So the way we saved this extracted entities, so we saved them comma separated. This is like we saved them in one column and separated with commas. So I can give you tell you right away. So this is the most approach because comma separated introduces ambiguity because comma might be part of some person's name, for example, last name, comma, first name. So in a business scenario, we would want to separate them with some or some to find some separators different from comma. But for this demo, we decided to keep it simple. And I will show you how we will search for this, because like if you have multiple values in one cell in the relation database, so you cannot apply the equality search. So you will either apply a partial search with the percentage characters, or like some database systems support regular expression-based search. I think that regexes are not yet supported, so we will use this percentage-based search. Okay, so now we have our data in this CSV file, and we are ready to actually upload now our data in knowledge base. So in MindsDB, we have two kinds of databases that we will work with when we think about creating a knowledge base. So knowledge base is created directly. So knowledge base is always based on some table that you have in your organization. So knowledge base just connects to this table. Well, you connect the knowledge base to this table, and you pull the data from this table into the knowledge base. So this table in which the data will reside before it's injected in the knowledge base. And also, which is different from the with respect to our previous tutorial, we will also use a different vector store. So first webinar, we didn't talk about vector store at all. I just created a knowledge base without mentioning it. But in MindsDB, there is a built-in support for two vector stores that you can use when it's base. So vector store it's a special database where you can store your embedding vectors. So when you transform your documents or chunks of some documents into numerical format for semantic similarity search, you need to store this vector somewhere, and you want this store to be fast enough to allow fast querying. So MindsDB supports out of the box two vector stores. One is ChromaDB, and another one is PG. So I believe that both are open source. So ChromaDB is used is a default choice. So if you don't specify any vector store to use, it will be ChromaDB, and it will run in this which the rest of your MindsDB stack is running. But if you prefer PG Vector, which is more mature and it has more resources and more configuration possibilities, then you can choose PG Vector. For this specific tutorial, we decided to show also how to switch to a different vector store, and in this case, it will be PG Vector. So we already have in our AWS environment a server running database management. So we will just connect to it. So different cloud providers provide PG Vector stores as a managed service. You just pay for the resources that you use. You don't need to install it, configure. It just based on your preferences. In our case, we will connect MindsDB to the store that was created for this specific demo. So this store is initially empty. So you don't have anything in it. You just have the name, and you connect to it using host port, like a usual connection to a database. So once we connected, so we connected to a vector store. What we will do, we will yeah, so I said the first step is to decide whether we use a vector store or not, and we decided then yes. And the second step before we can actually create a knowledge base is to create a table, like in our environment with the data. So the data, the original data that we split into different columns will be stored in this table, and the vector store will be ready to contain the embedding vectors once we generate them. So we already have our table in our data will be before we use it to create a knowledge base. So in MindsDB, there is a notion of a file. So file, it's a kind of a, you can take any file like CSV, you can apply into MindsDB, and there is a special table files, like a special database files that is built in, and all the files that you upload to this database become relational tables. So this is what we will do. So we will connect to the door, and we will upload our CSV into this files database. So you see all the records from our CSV have been uploaded into this files database. So now we have our data in the file and ready to start receiving vectors to store. So now we create a knowledge base. Okay, so we have two conditions satisfied. So when we create a knowledge base, we can just be like use a very simple format and use all the default parameters. So, for example, we can, if we don't put this, like this parameter storage, ChromaDB will be used. And this is what we did in our first webinar. But in this webinar, we decided to use a PG vector store. So we connect to the vector store and to keep our vectors in this specific table. So basically, your vector store can serve multiple knowledge bases. You just create a different table within the vector store, and here we add the suffix. So in our specific current case, it will be enron underscore vector. If I want to run it for the full, I will just change my parameter to full, and it will create a separate table with vectors specifically for the full database. Okay, so this one can be ignored, or it can be specifically put to use a different vector store. Then we can specify embedding model. I think that this one is important to specify manually because really the quality of your search will depend a lot on the actual embedding model that you use. So some of them are free, and maybe they're good, maybe they're less good. If you prefer to keep it simple, MindsDB comes with the connectors to various providers of models, and one of the providers supported out of the box is OpenAI, and they have this text embedding 3 large converts documents into embedding vectors, which has very good benchmark results. So this is what we'll use. Then another optional parameter that we haven't specified in the last time, but we want to show you this time is re-ranking model. So what does it mean? basically, when you do this semantic search, so you have a query and you have a collection of embedding vectors. So you embed your query into an embedding, and then you look for cosine similarity between your vector, your input vector, and all the vectors of the documents in your vector store. So this semantic similarity is a simple cosine similarity. So say you have, I don't know, 500,000 or a million embedding vectors. So you use this vector store to execute this cosine similarity search for you, and it returns the most similar document, like embedding vectors, the most similar to your input query. So this cosine similarity is usually providing reasonably good results. So the most, if the query and the document are the most similar, normally they're supposed to be somewhere close to the top of your output. They will be somewhere close to the bottom. But the issue is that then once let's say you have top 100 most similar documents to your input. So you want to show these the documents corresponding to these top 100 most similar embeddings to some language model and say, okay, answer this question given this 100 chunks of your documents, or the full documents that you use. The problem is that the context of models, language models, is not infinite. So if your chunks are large enough, if you use not top 100 but you want to use, let's say, top 1,000 to increase the chance that the right answer is somewhere among these thousands, you will start sending to your LLM that generates the answer. You will start sending very long queries, and this is an issue for multiple reasons. So first of all, the longer the input for a language model, the lower is the chance that the language model will not hallucinate. The lower is the chance that the language model will miss one of those documents because it will not pay attention to them. And it has been shown that language models pay more attention to the beginning of a long context or to it, but everything in the middle gets much less attention from language model. Another reason is that it will be slow, so there will be latency when you send this data to an LLM and wait for the output to be generated. The third reason is the cost. The context, the more expensive are your queries. So if you serve such a RAG system to your users and you have, let's say, millions of users, then it will be very expensive to run such long to send such long context to LLMs. So this re-ranking model can improve the quality of the top X results for you. So basically, what it does is that it takes your let's say your 100 candidates, and for every candidate, it pairs it to the query once again. But now the comparison is not based on cosine. The comparison is based on how the language model decides, like what the language model feels like how the query is relevant to the document. So the language model will then generate some numerical results, like, for example, this chunk is 90% similar. This chunk is 70% similar. So, and then based on this similarity scores, you can rerun your examples once again, and then take instead of taking top 1,000, you take top 10 to the more powerful. So that this LLM is not supposed to be costly or slow. So it's just a re-ranking. So that it will not hurt. So you can use a very cheap and very fast LLM for this. And once you have your best top 10 or top X, you send them to your powerful LLM for the final answer. Okay, so I think, yeah, the meta columns I already talked the last time, but again, for those who weren't there, so these columns basically mean that these columns will be copied directly from your original and becomes searchable within the knowledge base. The content columns is the command is very important. This is what the MindsDB they will convert into the embedding vector. So this one will not be converted into embedding vectors. This one will remain as is, but this one will be embedded and be saved in the embedding store. Okay, so now we create the knowledge base. Yeah, so the knowledge base is created, but it's empty. So it was connected to our vector store. It's ready now to send the embedding vectors to the vector store. But we'll put the data on the knowledge base. So to do it, we use a very familiar to everyone insert into select construct. So we will insert into the knowledge base from our files database with the CSV file data. And this command is optional, and you use it only when your data set is very large. So basically, when you use this using and you set batch size and threads, what you say is that the insertion will be asynchronous. So it will happen on the background. So it will use a batch size of 200. So it will insert the 200 rows from this files at the time. It was multi-threading for speed. And you can see you can poll the table while it's inserting to see the progress. So we will start it. It will return right away that it's complete, but it's not. Is inserting at this very moment. So now you can either use program like automate when the upload is complete, or if you're curious. Oh, sorry. Oh, we have again we have this issue with multi connections.
Right, let me take a look at that really quick, Andriy.
Yeah, last time I think you killed the
Yeah.
connection, right? Okay. Yeah, so because the cloud environment, so sometimes we put multiple threads and they're all consuming connections. And in this cloud environment, I think we already consumed everything. I can answer any questions if there are some while Alejandro kills the connection.
Also, for those asking, Badr, apologies if I mispronounce your name. Yes, you will get a full recording of Alejandro's presentation as well as Andrey's demonstration. We will share it in the next week, and we'll also share it on social media.
All right, Andriy, like maybe we can try again.
Okay. Okay. Well, we already while Alejandro killed connections, it actually managed to insert everything. So now we have all the records in the knowledge base, and you see it shows that we have the number of emails as we expected to have, but it says that it's in 7.360 chunks. So the one of the parameters that I haven't shown you in this demo, but it exists. You can find it in the documentation. Is the chunk size and the overlap. So basically, when you have long documents and you want to search within these long documents, and your approach is based on embedding similarity, if you embed the entire long document into one embedding vector, it will be more or less the average of the all information in this long document. And so let's say if the same document talks about strategy, financials, competition, and so on. So if you average all of this, it will become something like business. Okay, so if your query is very particular and it talks about like who are my competitors, and you have some documents that describe the competition, you would like that the part of the document about the competition was embedded separately from other parts. And this is where you can define the chunk size. For example, it would be, let's say my chunk will be maximum 1,000 tokens. Okay, and the problem with this chunking is that sometimes, because well, you don't know where this 1,000 will be applied, and the document will be chunked. So usually what we do, we introduce an overlap. So you chunk by 1,000, but every subsequent chunk is covering let's say 200 tokens from the previous chunk. So they always, like, they are not like this, but they're like this. So this maximizes the chances that the kind of unitary piece of information that was in the document, it will not be, it will be preserved at least in one of the chunks, and it maximizes the chances to identify it through cosine similarity. Okay. So, and there is no right or wrong way to chunk. It's all like based on the data that you work with. So this is why it's very important to actually read some of the documents in your data set to see what they look like and what kind of chunking would be and overlapping would be appropriate for it. Okay, now we have our knowledge base, but it's a very tiny knowledge base. It's a sample, so I will show you how we ask questions, and then I will switch to the full knowledge base that we prepared beforehand, so that we will actually be able to answer our questions. So to answer questions from the knowledge base, it's quite simple in SQL. So basically, give me a sec. Yeah. So basically, the core of the query is like this. So you do select, and you can specify what kind of columns you want to select, and in the from you put your knowledge base name as if it were just a normal relational database. In the where you put all the attributes of your select that you want. So for example, let's say you want to search with some attributes. So for example, let's say you want to search where the name of the person is John Smith. Okay, so in this case, you add to your where clause. This will be our names, and as I explained, because our names are concatenated with a comma, so if I want to find all emails where the from contains John Smith, or not from, let's say persons contain John Smith, I will use like, and I will put these two question marks, and I will put my John Smith here. So if John Smith is somewhere in the list of persons extracted in the email, this like will match. Then you will also need to add the content equal to. And here you put your question, just like, for example, what did John Smith said to Mary J about the problem in the company? So in the content, you put this question. So this question will be embedded into a vector, and then all chunks that contain potentially an answer, because they are semantically similar, will be selected. So to make it more interactive, I created a function that takes the question as input, and also as optional parameters, it takes every person you want to filter by, organization, locations, and all other attributes extracted by NER. And also you can put, let's say, from and to as email addresses, the date, and well, there are some other fields. So in the end, it will create this where clause based on all the parameters that the function has received, and it will just run this query using the MindsDB SDK. And it will, well, the result of this query will be rows in the knowledge base with chunks that are the most semantically similar to our search query. And then we will take all this, well, not all this, but 50 in this case. We will take 50 chunks that are the most semantically similar to the query, and respecting our attributes like names, locations, from, to, and so on. And those 50 chunks we will send to our powerful LLM to actually look at the question, look at the 50 chunks, and write an answer if the answer is contained in these 50 chunks. Sometimes it's not. If there is no document that actually can answer your question, then top 50 will still contain something, but not necessarily the most relevant document. And your language model will most likely say, looking at these chunks, I couldn't find the answer to the given question. So by the way, this is called grounding. So when in LLM you just ask a random question and it gives you some answer, it can be hallucinated or not. You don't know. But if you put the actual information on which you want the answer to be based, this is called grounding. So the LLM is instructed to only answer the question based on the provided information. Of course, it will not exclude the hallucination 100%. It's never possible, but the chances that the answer will be actually based on the real data with grounding are much higher than when you ask the LLM like in a vanilla scenario where it answers directly from its trained parameters. Okay, so we have this one question here. I will just so this is the actual question. So one of the executives in one of the emails justified that they overstated the valuation of a company. So it was supposed to be valued at 250 million, but they decided to declare that it was 600 millions. And so we launch. And yeah, so to reduce the possibilities for emails, I added these additional parameters. So in the query, it will be where persons like, and this will be last name. So it hasn't found anything because, well, our database is, I know, it has found something finally. Yeah, so it found 49 chunks. And yeah, so this is what I said. So our language model received all these chunks, and based on the question and the chunks, it decided that the chunks don't provide the answer to this question, which is normal because our knowledge base currently contains only 1% of all emails. So now let's switch to our actual database. So I will set mode to full, and the suffix will be full too. So normally if we haven't broken anything, now it will use the full the full knowledge base. Okay, so we have 50 results. Yeah, okay. So now among all those 50 most similar chunks, the LLM actually identified the right answer, and it says that David Delaney justified the increased valuation by citing several factors. According to this email, mentioned that So it gives you the actual emails, like chunk IDs or emails, if you want, to provide, like when you search, let's say with current chatbots, they give you the answer and then they provide links, and you can click on the link and see if the answer actually was based on this link. So this is the same situation. So if you want in your product to let the user not just read the final answer, but actually trace it back to the original document, you can just ask the LLM by saying, like, when you answer you give the final answer, every statement taken from a specific chunk should be accompanied with the ID of the email from which the chunk was extracted. Again, not 100% guarantee, but at least user will be able to click to see whether what's said here actually corresponds to what was in this email. So it's like it gives you a possibility to double check the answer. And we will test on one more question, like how did Tim Despain coach Ken Lay on what to tell credit rating agencies about Enron's financial situation. And we will filter by organization, so we will only consider emails that mentioned Moody's. So we will search. Okay, so again, 50 results and the answer. Team Despain coached Ken Lay on what to tell credit rating agencies in this email, and then again, email ID. He emphasized the importance of maintaining credit rating, stress that Enron is committed to maintaining credit rating. Suggested that Lay should communicate that the Enron's core business are strong and that the company is leading franchise and energy marketing. This proactive communication was intended to positively impact the message delivered by analysts to their committees at Standard & Poor's and Moody's. So if you want to read the actual email, you can create a UI where the user clicks, it opens the email, and the user can find the actual words that have been said. I think this is it. I think here I also have some interesting statistics about the knowledge base. So no, it's still. No, it's still showing the small database. I haven't updated names, so no, we will not see any. Well, we will see an interesting statistics for a sample. So you see that for about 5,000 emails, we have 600,000 words, 124 words per email. Yeah, well, this is just, where you want to do some sanity check after you create a knowledge base to see if you see some really weird numbers. If you feel like the numbers are weird, you can revalidate your script and to make sure that everything was processed and injected as expected. This is it. Any questions?
Amazing. Thank you so much, Andriy. Okay, so we have gotten to the Q&A portion of the webinar. If you have any questions, feel free to pop it in the Q&A tab, or seeing as this is the end of the webinar, you can also just put it in the chat and we will read it aloud, and we will respond to you live. I have just sent a link to our documentation in the chat as well. Feel free to check that out. If you have any further questions, we will be waiting until we end things off.
In the meantime, I think it's worth Andriy, this is fantastic. And just to get a grip of like what we have done in this last hour, we uploaded all these emails, put in a knowledge base. We can ask questions specifically about different contents. When this investigation was originally done in 2002, the FBI employed 600 people over 8 months to read this 500,000 emails. So you can see like with the power of AI and really how this is really changed. So something that probably cost tens of millions of dollars to investigate and read all these emails, we just did it on MindsDB open source. Thanks to Andriy's like visibility and insights into this. So really cool stuff. Thanks, Andriy.
Sure. Yeah, and also if you think about everything legal today, like for example, find the different existing jurisprudence for some case. Previously, lawyers employed different a lot of paralegals, and it was a very hard, mentally very hard task to dig through thousands of potentially relevant cases, trying to find some precedent that you can use. But today you upload it exactly the same way as we uploaded the emails, and you just paste your original, like your current case, and you ask it find the most similar previous cases that I might want to evaluate. And it will work just like this. In a matter of minutes, you will have access to such engine. And previously, there were company like this whole legal domain was called e-discovery. Basically, like companies charge like millions of dollars to create such search engines for lawyers to use. But now, like if you use chatbot and you use MindsDB, which is open source, you will create your own search engine like in a matter of a week, like if you include UI and the rest of stuff.
Yeah.
Amazing.
All
Andriy
right.
just showed you. Apologies, Alejandro. I just wanted to say Andriy just showed you a way to save time and money.
Mhm.
Um, we do have a couple of questions for Alejandro and Andriy. I will read them out loudly, and then Alejandro or Andriy, you can just respond. So let's answer them live. The first one will be, how would you go about ingesting PDF documents instead of emails?
Yes. So one of the beautiful things about knowledge bases, it's about like, can you actually ingest unstructured data and structured data? So MindDB allows you to search via knowledge bases and semantic meaning using structured data, as we just see before. But also most of the unstructured data of the world is in format of PDFs or in other type of formats. So we have a function called the to markdown that the main concept of MindDB is that everything is on tables. So we have functions to transform these PDFs into tables and then therefore can be ingested into a knowledge base. So this is transparent to the user, but just how the inner workings of MindDB works. So feel free to jump into the documentation and use the to markdown function, or which transform any PDF document into markdown and therefore goes inside a knowledge base.
Amazing. Next question is, how do we ensure similarity match does not lead to false positives and providing the LLM wrong data and thereby leading to hallucinations? What guardrails can be employed to avoid that?
I can take a first pass, Andriy, and feel sure to complement my answer. So when using knowledge bases and similarity search, yeah, there might be the possibility that because we similarity that you might bring some wrong concept into it, right? Like, for example, you might search for like best restaurants in France, and it will find some similarity between France and perhaps something in your database that will probably not really answer the question, and that's going to be inserted into your RAG pipeline. So the way that we do it in MindDB is a couple of ways. Like one is a re-ranking model that will actually help out to see all the chunks returned by your knowledge base, and it will actually see if they actually match the query or not. So like it kind of works like as a filter using that re-ranking model. And also I think like in the end, it's also all about like evaluations and evals. So you can use the evaluation tool in MindDB to like generate all this type of questions that you know the answers that are going to be tricky, and you can actually evaluate like how good the system is performing and bringing those answers to you.
Yeah, and just to to complement Alejandro's answer, so like they could be no, you cannot create a fully automated system that always find the right answer, or it at least confirms that the right answer doesn't exist in your knowledge base. So in the search theory and overall in machine learning, we have the concepts of precision and recall. So recall, it's a property of an information system that tells you that if the answers were actually in the knowledge base, what is the percentage of these answers that have been identified? So there you would like to recall to be 100%, of course. So basically for all queries that you make, you always find the answer when it's there. But there is no information system with recall 100%, except if you return all the documents every time. Okay, so you have your knowledge base of 500,000 emails, and for every query you return 500,000 all the time. Yes, the recall will be 100%. You are happy, but there is another parameter called precision, and precision will measure how many in how many cases the returned document was when the system says this is your document, that this was the case. And if you return 500,000, the chance that all of them is what you search are zero. So there is total like constant kind of trade-off or a struggle or a battle between precision and recall. So you can maximize one by minimizing another. You can maximize another by minimizing one. So the only so there is a parameter called like a metric called F1. It's a kind of a combination of precision and recall. And what Alejandro told you, that MindsDB comes with this evaluation subsystem. So you can you can compare different embedding vector engines, not engines but models. You can compare different re-ranking models. And you can see for different combinations of these embedding models and re-ranking models for your data, what is F1 in this case, and you can just optimize it for your specific data to have this F1 as high as possible. So this is kind of from the general information system building perspective. And then yeah, in the question there was a part about guardrails. Of course, if you know your data well, then you might think, okay, if the answer is correct, it's supposed to contain this specific part. And you can apply this post-processing, and you will check whether this specific part is there. For example, you might instruct your final LLM that generates the final answer to only write the answer based on the excerpt extracted from the emails verbatim, without any modification. And then after every verbatim text, you can instruct it to put the link to the actual email it was based on. So this is verifiable automatically. So you take this verbatim piece, supposedly verbatim piece, and you go to this email and you see if there is a match. If there is no match, you say, no, I don't accept this output because it's not verbatim. So potentially it's a hallucination. So in this case, you will end up only having verbatim verifiable answers, but you will reduce the number of situations in which you will have this answer. So this will reduce your recall. So if you're ready to sacrifice a little bit of recall to always get verifiable answer, you can. And if the answer is not verifiable, you can ask a human to read everything and actually certify that the answer was correct. So by adding human in the loop and adding some additional very strict guardrails, you can find a good trade-off between money spent on this additional human labor and the quality that you obtain.
Amazing. Thank you so much, Andriy and Alejandro. And for our last question, because I see there aren't any more, how do we automate the data ingestion dynamically if the data refreshed at the sources?
Okay, I can tackle that one. So in MindsDB, we have a tool called jobs. So you can set up these jobs to be automatic jobs to be able to maintain your knowledge base fresh. So you can set up a job as an example, like if a row is added into your original data source, then automatically added into a knowledge base. So with the jobs, you can see in our documentation, you can actually automate different processes to make sure that your knowledge base is always fresh and up to date.
Amazing. Ashok, I've also shared the link to our documentation on how to create jobs as well. Okay. And then we have another question, which will be our last one. What is the acceptable latency when deployed in production?
Oh, this is a very good question, right? Because when we're thinking about production, we're thinking about latency. Of course, the faster it does, the faster we'll get. And what's acceptable, I think, like, will be dependent on your use case. But the way that we have is built MindsDB, we're really trying to focus to make it as fast as possible in order to bring you the right answer. And we built a couple of tools, like you can create HNSW indexes on your Postgres vector store, and that will improve querying speed, but sometimes by 8%. Also moving sometimes the hardware will also like able to do that into a faster and better response. In general, I would suggest that queries in terms of a knowledge base should at least be no more than 5 seconds. And if you have more than 5 seconds, I think like we need to be able to look at how to optimize those queries, either by creating an index on that vector store or by like looking a little bit more into hardware. But in principle, vector store query searches and vector similarities should not take a long time.
Amazing. Thank you, Alejandro. A special thank you to Andriy Burkov for taking the time and giving us an amazing presentation. We really appreciate it. Also, thank you to Alejandro for answering questions and providing us with a brief presentation about knowledge bases. And then lastly, thank you to all of the attendees. Thank you for your questions and thank you for your time in seeing what we are doing at MindsDB and also seeing Andriy's use case as to how you can apply MindsDB. So I hope that you guys enjoyed it and hopefully we will see you guys soon. Any further questions, feel free to pop a message in our community Slack. Let me just share the link with you guys again once more. I'm going to share the link in our chat. If you have any further questions, please join our Slack community. We will answer any questions that you guys have. Hopefully you will join us in the future when we have another webinar with Andriy. So enjoy your day, guys. Thank you so much for attending. Bye.
Thank you. Bye.
Thank you very much, everybody. Thanks, Andriy.
Yeah.